Welcome back to Chem Talks. Today in Chem Talks we are going to continue with our discussion of the atom. Remember in the last lecture we talked about the developments and the contributions of scientists that led up to our current understanding of what the atom is. Now remember, this may not be exactly right, but it's the best of what science knows about the atom today. So today what we're going to do is start talking about the parts that make up the atom, or the subatomic particles. So let's go ahead and get started. The first thing we should do is simply define an atom. An atom is the simplest part of an element. It contains all the properties of that element, both physical and chemical properties. And all atoms of the same element are virtually identical. There are some slight variations that we'll talk about as we go on, but for the most part we can consider them to be identical. Now, atoms are composed of a nucleus and what we call a large cloud of electrons outside of the nucleus. So we're going to start today's discussion with looking at the nucleus. The nucleus is the central core of an atom. It's made up of two parts, and those are the protons and the neutrons, two of the three subatomic particles. And even though the nucleus, we can see it there highlighted in yellow, is very small, it makes up a very small portion of the atom itself, it's going to contain most of the mass, because it's the protons and neutrons that contribute to the mass. The electrons, which are around the outside, are so light we don't really consider them in the mass, at least at this level of chemistry. The first subatomic particle that we want to talk about is the protons. And protons are the positively charged particles found in the nucleus of atoms. They have a positive charge. And protons are really important. A proton of one type of element is going to look identical to the proton in another element. What's important is when those protons come together. They are what gives an atom its identity. It's what separates one type of element from another type of element. So the number of protons is the same among all atoms of the same element. So all oxygen atoms, for example, will all have 8 protons. All carbons have 6 protons. All hydrogen atoms have 1 proton. We abbreviate protons with a P for proton and a plus for a positive charge. So it's a good way to help you remember the charge of it. The other thing that's important to know about protons is what we call the atomic number. An atomic number simply refers to the number of protons in a nucleus. And it's this atomic number which is used to organize the element within the periodic table, because it doesn't change. If we were to change the number of protons, we've changed that one atom to another, and we can't do that. So the atomic number simply refers to the number of protons in an atom. Okay? If we look at this example here of oxygen, okay, the 8 at the top of the whole number, that refers to the atomic number, or oxygen has 8 protons in it. The other thing inside the nucleus is the neutrons. Like the name implies, neutrons are neutral, or they have no charge. They're found inside the nucleus with the proton, but unlike the protons, the number of neutrons in the nucleus can vary between different atoms of the same element. And we call these isotopes. Isotopes are atoms of the same element with different number of neutrons. And we can abbreviate them with an NO for O for the no charge, or a capital N. You'll see it either way. Once we know the number of protons and number of neutrons in an atom, we can come up with what we call the mass number. Mass number is simply the protons plus neutrons. So look at this example here of oxygen. Oxygen has 8 protons. How do I know it's oxygen? Well, if I look at atomic number 8, its element oxygen. So if I have 8 protons and 8 neutrons, I add them together, you get a mass number of 16. When I write this out, what you'll see is the O for oxygen and 16 on top. That's our mass number, and then the 8 below gives us our atomic number. I would describe this atom as oxygen 16. Now if I had an oxygen isotope that had, let's say, 10 neutrons, given us a mass number of 18, I'd call it oxygen 18. Making the name of the element, then the mass number. And from the mass number I can figure out the number of neutrons, because I know the atomic number is always the same. So there's our 16, that's our mass number of this. outside of the nucleus, we find the electrons. And the electrons are negatively charged particles that form the electron cloud around the nucleus. Okay, we can see an example of a single electron right there. The mass of the electron is going to be very small compared to the mass of the protons and neutrons. So like I said, when we figure out the mass of a single atom, we don't really take into account the mass of electrons because it's so small. We abbreviate it with an E for electron negative, so E negative is our abbreviation for electrons. What we see is that electrons have a very high energy and they travel around the nucleus at very high speed and what we call energy levels. This is that electron cloud. You'll hear the term orbitals. Okay? And each energy level or each orbital can hold up to a certain number of electrons. Perhaps you've learned in previous science classes that the first level holds 2. The second energy level holds 8. The third energy level holds 8 again. The fourth is 18. We will get into more in depth on that and describing exactly where those electrons are in a later episode. But know for right now that each orbital, each energy level can hold a specific number of electrons. Measuring the mass of a single atom, it is very, very small. Okay, so scientists have developed something called the atomic mass unit, abbreviated AMU. It's the units that are used to measure the mass, or kind of think of it as the weight, even though weight's not the correct term, of an atom. And 1 AMU is equal to 1/12 the mass of a carbon atom. So I used a carbon atom as a reference because it's got 6 protons and 6 neutrons for carbon 12. And we took 1/12 of that, and that's the mass of, or that's what 1 AMU is equal to. It's approximately about the mass of 1 proton. So think about that. So whenever we're weighing a single atom, we're going to use AMUs to measure the mass of that out. Okay, if we look at an example, here's chlorine. We can see our top number, our whole number, 17. That's going to be our atomic number. So all chlorine atoms have 17 protons in it. Now the number at the bottom is 35.45, is our atomic mass. And we can define atomic mass as the average mass of the atoms of an element. It's expressed in AMU. So we'd say 1 chlorine atom on average weighs 35.45. But now here's the question. We said it's generally the protons and neutrons that make up the mass of it. So why isn't this number just 35? Why is there a decimal place? Well, this is because of the isotopes, the different variations of the chlorine. When we figure out the atomic mass, we have to take those into consideration. Okay, so all the different variations of atom are taken into consideration when we get the mass. So we average them out, and when you average, you end up getting a decimal place. We'll talk about more how we figure that out next episode. Another variation of an atom is what we call an ion. An ion is simply an atom that has a charge. So the question is, how does it get a charge? Well, there's 2 charged particles, right? There's protons and electrons. Well, if we change the number of protons, we end up with a different element altogether. We know we can't do that. So what we see is that we must change the electrons. So the charge, an ion being a charged atom, it's because that atom has a different number of protons and electrons. It's either gained or lost electrons. Okay? So ions have gained or lost electrons, not protons. Remember that. We can't change the number of protons. We change the number of protons, we change the elements. That's what alchemists tried to do back in the Middle Ages, turn lead to gold. You can't do that. They're too tightly bound in the core, and it's used to identify the elements. But you can change the number of electrons. Okay? And atoms will either gain or lose electrons based on their location in the periodic table, because where they are in the location in the periodic table tells us where they are, where their current electrons are located. So there are 2 types of electrons. So let's look at this for one first. The first type is what we call cation. And cations are atoms that will lose electrons. So if you lose electrons, you will have more protons than neutrons, which means you have a positive charge. Okay? So cations lose electrons. You have more positive charges now than you have negative. So if you lose 1 electron, you become a +1. The other type is what we call an anion. And anions gain electrons, so they gain a negative charge. Well, if you gain an extra negative, you'll have more negatives than positive, and you'll become negatively charged. Okay, so cations lose electrons, become positive. So cations are positive, and we generally find those on the left-hand side of the periodic table. Anions are negatively charged because they gained electrons, and we find those on the right-hand side of the periodic table. So 3 basic parts or subatomic particles that make up an atom. In the nucleus we have the proton and the neutrons, and then outside those we have the electrons. The atomic number refers to the number of protons, and it's what gives an atom its identity. The number of protons can never change, but remember, the number of neutrons can't. If the number of neutrons are different between atoms of the same element, we call them an isotope. Like the neutrons, and electrons can change. They can be added or taken away. In that case, we get an ion. A positive, if we add electrons, we become negative charge, which is called an anion. If we take them away, we become positive charge, and we call it a cation, as in our little cat here. Okay, guys, make sure you took good notes. If you're not understanding it, go back through and watch this again. Otherwise, I will see you in class. Talk to you later.